I'd like to mention R squared. R squared measures the percentage of variance and explained. And let me be even more specific. It measures the percentage of the variance in the dependent variable explained by the independent variable. Let me read this brief description. An alternative method for measuring effect size is to determine how much of the variability in the scores is explained by the treatment effect. What do we mean by the treatment effect? The independent variable. What do we mean by variability in the scores? The dependent variable. The concept behind this measure is that the treatment, the independent variable, causes the scores to increase or decrease, which means that the treatment, the independent variable, is causing those scores to vary. And of course, the scores are the dependent variable. If we can measure how much of the variability in the dependent variable is explained by the treatment, which is the independent variable, we will obtain a measure of the size of the treatment effect. We'll come back to this. We're going to put this in the context of two problems, but this first sentence is perfect. An alternative method for measuring effect size is to determine how much of the variability in the scores in the dependent variable is explained by the treatment effect, which is the independent variable. What's that formula? It's beautiful. Look at that. Couldn't be simpler. By the way, that's t obtained. That's important to say. That's the obtained value of t squared divided by the obtained value of t squared plus the degrees of freedom in the problem. You'll notice something, and I'll draw your attention to this briefly. The larger the sample size, it actually reduces r squared. So if I had, 200 participants, this would be 199 degrees of freedom, and that would lower the r squared. So in a way, this is taking into account large sample sizes. It's kind of baked in. Conversely, if I had a really big effect, and therefore a big t, and a small sample size, the value of r squared would be very large. We'll have two examples of this later. I think it'll be very clear. It's not terribly involved at all.